I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
We have the same thing with acute and 3D. We have now perpendicular and 3D, which means you have to get a cosine of 90, which you have the dot product of 0. As a thing. So you have Cartesian coordinate system, x hat, y hat, z hat. Remember that? This is like a really something that we have been using a lot of time right now. We're going to get the magnitude of each of the vectors in a component because we know that dot product gives us a scalar. And the thing is, even if we want to get from the components the dot product, we still have to use scalars to get the dot product. So we're going to use the magnitude of each of these to be found out. So we found 8 is square root of 41 because remember all the components are going to be now raised to the power 2, and then square root of the sum of all of them is going to be the magnitude, so it's going to be square root of 41. For b it's going to be 1 because we have two actually scalars being canceling each other out to give us 1. C is going to give us 2 because we get square root of 4 and then we get 2. D, vector D is going to give us square root of 1, which is going to be 1. And then vector E is going to give us square root of 13, and then vector F is going to give me the square root of 8. So by doing that, we get all the magnitudes, and then now we have the chance to find out, okay, now that we have all of these, how can we get a perpendicular vectors to work this out? So now I'm going to erase all of this, and we're going to come back to see what we can do to get a perpendicular dot product using these. So now that we get our magnitudes, now it's time to get the dot product. So I find out that we have the Cartesian coordinate system. We're going to get x hat, y hat, z hat. Remember that's a Cartesian coordinate system. They're all purely perpendicular. So z hat comes out of the word. Z hat comes out of the board. X hat goes to right and y hat goes to up. So C is going to, when you put vector C and vector B together, we're going to get a 90 degrees angle. No matter how you guys look at it, you're going to get a 90 degrees angle, so we're going to put them together. So when you do B times C, we're going to get 1.2 for 1 times 2, and then cosine of 90 because that's going to be the right angle to get a perpendicular. So we're going to get 0. Because remember, the rule is if you have a cosine of 90, it's going to be 0. So if you have two vectors that are perpendicular, they're going to get a 0 dot product. And remember, this is scalar because we use scalars that we got from components to make it a dot product. And this is pretty much how you get the dot product, from using the components and getting them to magnitude and using them inside the problem to try to get a cosine of 90. So hopefully you guys really like this idea of how we do it. If you guys have any questions, let me know in the comments. Remember to also use different unit vectors for this because we have scalar and dot products give us a scalar, does not give us a vector. It's going to give us a scalar. So hopefully you guys understand, and I see you guys in next videos.